Part A. Explain briefly how the ocean waves are created by wind and gravity. Ocean waves are generally caused by wind and gravity. Wind-driven waves in ocean as well as tsunami waves and tidal waves are some examples of gravity waves. When wind blows across the surface of the ocean, water surface of ocean is continuously disturbed by the wind. Under this situation, the force of gravity tries to restore the equilibrium at the surface between water and air. As a result, ocean waves are created. Now we have to get the answer. Explain briefly how the ocean waves are created by wind and gravity. We can write, when wind blows across the surface of the ocean, water surface of ocean is continuously disturbed by wind. Under this situation, the force of gravity tries to restore the equilibrium at the interface between water and air. As a result, ocean waves are created. We can write directly answer by using the sentences in paragraph. Then B. What is the difference between deep water waves and shallow water waves exist in the ocean? Then I will read again. As a result, ocean waves are created. Ocean waves can be categorized into two main types, namely deep water waves and shallow water waves. The terms shallow water waves and deep water waves have nothing to do with the true depth of the ocean. The waves present in the ocean, where the depth edge of the ocean is greater than half wavelength of the wave, called deep water waves. When the depth edge in the ocean is less than half wavelength of the wave, they are called shallow water waves. We can write it as the answer. Depth of the ocean is greater than half of wavelength. It is a deep water wave. And depth of the ocean is less than half of wavelength. It is called shallow water wave. We have to write answers directly by using sentences in given paragraph. Part C. What are the three causes of tsunami waves, wave formation mentioned in the passage? Then I will read again. The wavelengths of deep water waves are ranging 1 meter to 1 kilometer, whereas the wavelengths of shallow water waves are in the range 10 kilometers to 500 kilometers in the ocean. The value of speed of propagation v of shallow water waves in the ocean of depth h is given by v equals root gh. The average depth of the ocean is about 4 kilometers. Major tsunamis are caused by a large scale disturbances in ocean, such as underwater earthquakes, volcanic eruptions occurring on the below of the ocean floor, and impact of a large meteorite with ocean. A tsunami is scaled of ocean waves with a very long wavelength. Now we can write, we have to write three reasons. There are three reasons in paragraph: underwater earthquakes, volcanic eruptions, and impact of large meteorite with ocean. Then part D. Identify the type of tsunami waves possible in ocean, deep water wave or shallow water wave, and estimate the speed of tsunami wave in meters per second. The ocean having an average depth of 4 kilometers. Tsunami is a series of ocean waves, very long wavelength range, 10 kilometers to 500 kilometers in the ocean. Now, they have given that wavelength of shallow water waves in the range of 10 kilometers to 500 kilometers. Now they have given range of tsunami waves 10 kilometers to 500 kilometers. Therefore, we can write tsunami waves are shallow waves. Then answer for part D. We can write shallow water waves. Now we have to calculate the speed. When calculating speed, they have given an equation v equals root gh. G is the gravitational acceleration. We can use it as 10. Depth of the sea for the corresponding calculation is given as 4 kilometers, 4,000 meters. Root 4 to 200 meters per second. Then part E. The height of tsunami wave rapidly increases as it approaches shallow water near the coast. Explain the qualitatively why this happens. The height of tsunami wave rapidly increases. We can get when it comes to the coast, it is decreasing. You know that depth of the sea is decreasing when coming towards the land. Therefore, according to this equation, V is decreasing. And according to V equals F lambda, we know that frequency is constant. Frequency is constant for the corresponding wave. It is dependent only on source. When velocity decreases, wavelength should be decreased. Then wavelength is decreasing. When wavelength is decreasing, we can get for this wave, wavelength is this one. For this wave, wavelength is this one. When wavelength decreases, height of the wave should increase. Height means amplitude. Then amplitude increases. We can write, therefore, height is increasing. We have to write only qualitatively. It means we can write answer without calculation. Part F, calculate the height of tsunami wave at the ocean at a place where water depth is 6,250 meters. Take the height of water depth 10 meters. Depth of 10 meters. Height of wave at water depth 10 meters as 5 meters. Consider the depth of tsunami. Explain why it is difficult to determine tsunami waves in deep ocean. I will read passage again. Major tsunami. Tsunamis are caused by the large scale distribution in the ocean, such as underwater earthquakes, volcanic eruptions occurring on or below ocean floor, and impact of large meteorite with ocean. A tsunami is a scale of ocean waves very long wavelengths, ranging from 10 kilometers from 10 kilometers to 500 kilometers in deep ocean. Even though the shape of tsunami waves can be approximated to a sinusoidal wave in the deep ocean far away from the shore, it gradually takes a complex from as it reaches the shallow water near the coast as shown in the figure 1a. Depending on the weather, the first part of the tsunami wave which reaches the shore is a crest or a thought. It may appear rapidly, rising or falling tide. In some situations, the front of the waveform can take very complex shape near the shoreline as shown in the figure 1b, and it may appear as a rapidly descending of the shoreline followed by incoming huge wave, height grown up to several meters. The rate of transfer of tsunami wave energy through the ocean surface, which depends on both its speed and wave height, remains nearly constant. In general, the value of the height h of tsunami wave as entered shore water is given by hs equals hd times simple hd over hs to the power 1 over 4, where hd is the wave height in deep water and hs and hd are the depth of shallow and deep water respectively. Now we can use that equation to calculate. For the calculation in part F, hs equals hd times hd over hs to the power 1 over 4. Calculate the height of tsunami wave in the ocean at a place where depth is 6,250. Take the height of wave at water depth of 10 meters as 5 meters. Now we have to calculate the height of tsunami wave. Place under the water depth is 6,250. It means we have to calculate HD value. Height of tsunami wave in deep water. HS is given as 10 meters. HD 6,250, HS 5 to the power 1 over 4. 5 divided by 5, 1, 2, 5, 0. Now we can subject HD 10 divided by 4th root of 1,250. It is in meters. We can simplify it by using logarithms. I will not do it now. Part G. Assuming that tsunami wave takes the shape shown in figure 1b at the shoreline. Explain briefly why the shoreline records from the land just before arrival of the huge mass of water. We have to consider figure 1b. We can write directly amplitude of water wave. Amplitude of wave is a higher value. In part H, if the tsunami wave mentioned in question G above can be approximated to a part of sinusoidal wave as figure 3. Calculate the time duration in minutes between instant that the shoreline starts recording into the ocean and arrive the water mass at the former shoreline. From part sinusoidal wave, take V equals 10 meters per second and lambda wavelength is 18 kilometers. We can consider the corresponding waveform. It is like this. We have to calculate the time taken to come this point to this line. They have given that wavelength is 18 kilometers. Now we can get it as 3/4 of wavelength. This part is 3/4 of wavelength. Therefore, we can use S equals ut for the corresponding wave. Distance should be this part. It is 3/4 of wavelength. 3/4 of wavelength should be equals to velocity of wave is given as 10. We have to get time. 3/4 wavelength is 18 kilometers, 18,000 meters. Now this one is the time in seconds. We have to convert it to minutes. I will simplify it. Divide by 4, 1. Divide by 4, 4, 2 remaining. 20 divided by 4, 5, 0. 0, 3 into 5, 15, 1 remaining. 3 into 4, 12 plus 1, 13. Seconds. Time in seconds. We have to convert it to minutes. 1350 divided by 60 minutes. 13 divided by 6, 2. 12, 1 remaining. 15 divided by 6, 2. 3 remaining. 30 divided by 6, 5. 22.5 minutes. Part I, figure 2. Shows some locations where a wave, where the wave height is very high compared to their adjoining regions, having a very low wavelength. What phenomenon could be responsible for this? Explain your answer. When tsunami waves propagate across the ocean, the wave crest can undergo refraction. It is caused by segment of wave moving different speed as in the water depth along the water crest varies. In addition, due to uneven variation of the ocean flow near the coast and obstacles such that small island reefs on the tsunami path, this wave undergo interference and diffraction. The distribution of tsunami wave heights was estimated by the group of scientists along the coastline of Sri Lanka after the devastating tsunami that has occurred in December 26, 2004. The length of the lines in figure 2 shows the height of tsunami wave crest along the coastline. Superposition of waves from the primary source and reflected and diffracted waves from obstacles was responsible for the erratic pattern of the wave height and varying damage along the coast. Now we can write the answer for part I. Superposition of primary source and refracted wave. We can write directly superposition. Superposition of waves. In part J, briefly explain reason why tsunami waves in 2004 reached over the west coast of the island, shown in figure 2. It is the reason for it is the diffraction. We know that when a barrier is meeting, the wave will change its path like this. Then we can write answer for part J, refraction.